In this video, we will describe the properties of polynomial functions and sketch its graph. In graphing polynomial functions, we can follow these steps. First is identifying the intercepts, the x-intercepts and the y-intercept. Second, determining the zeros of the function, and these zeros are called x-intercepts, and their multiplicity, and determine whether the graph crosses or touches the x-axis. Third, determine where the function is greater than 0 or where the function is less than 0. It means we will determine where the graph of the function is above or below the x-axis. Fourth, determine the end behavior of the function. And last one, based on this information, we can sketch the graph with a smooth curve and label the intercepts. As an example, let us analyze and sketch the graph of the given function f written in a factored form. So the first step is finding the intercepts. To find the x-intercepts, or the zeros of the function, we replace 0 in the given function y or f of x. And then we will equate each factor to 0. So the first factor is 3x. Let's equate to 0. So when 3x is equal to 0, dividing both sides by 3, we will get x equal to 0. Then the second factor is 1 minus 2x equal to 0. So when we equate 1 minus 2x to 0, we move 1 on the other side and then divide both sides by negative 2. We get x equal to 1/2. Then the third factor is x minus 1 squared equal to 0. We can ignore the power 2 because if we will get square root of both sides, square root of 0 is still 0. So we can equate x minus 1 to 0 and we get x equal to 1. And then for the last factor, x plus 1 cubed equal to 0. And we can also ignore the power 3 because if we will get cube root of both sides, cube root of 0 is still 0. So we can have x plus 1 equal to 0 and we got x equal to negative 1. So there are 4 x-intercepts, 0, 1/2, 1, and negative 1. And these are the zeros of the function. Let us proceed in finding the y-intercept by setting x equal to 0. If we place 0 in x here, we know that 0 times any number, we will get 0. So that's why the y-intercept is equal to 0. So now to summarize the x-intercepts, we have x-intercepts negative 1, 0, 1/2, and 0. And these are how you will plot the x-intercepts. And then for the y-intercept, y is equal to 0. So there's only one y-intercept. So that's how you will put the x-intercepts and y-intercept in the graph. The next step is finding the zeros or x-intercepts, their multiplicity, and their behavior near the zeros. Multiplicity is the power of each factor. If the multiplicity is an odd, then the behavior of the function near 0 crosses. So when it is 1, it crosses like a line. And if it is greater than or equal to 3, like 3, 5, 7, and so on, it crosses like a curve. But if the multiplicity is an even, then the behavior of the function near 0 touches. So for this given function, the first factor is 3x, and we know that the 0 here is 0. So to find the multiplicity, since the power of x is power 1, the multiplicity is 1. And since multiplicity is an odd, or 1, then the behavior of the function is 0, crosses. So to describe this or to show this behavior of function near 0, so at 0, at this point, so the graph can be like this, so it will cross like a line, or like that. The next factor is 1 minus 2x. So in 1 minus 2x, the 0 is 1/2. So 1 minus 2x is with power 1, so its multiplicity is 1. And the behavior of the function near 0 crosses because it's an odd again. Since multiplicity is 1, so it crosses like a line. So at 0, which is equal to 1/2, the behavior of the function near the 0 is either this or like that. Then the next factor is x minus 1 power 2. And the 0 here is 1. Since the power of x minus 1 is 2, so its multiplicity is 2. Since it is even, then the behavior of the function near 0 touches. So let us locate the 0, which is 1. So in this point, the behavior of the function will touch like a parabola opening up or a parabola opening down. And then the last factor is x plus 1 cubed. And the 0 here is a minus 1. And the power of this x plus 1 is power 3, so its multiplicity is 3. And the behavior of the function near the 0 crosses like an x cubed or like a curve. So at minus 1, at this point, the graph can either be this or the other way. Now let us find the end behavior. In finding for the end behavior, we need to get the leading term of this function. So instead of expanding this function to get the leading term, what we can do is we will get the leading term of each factor. So for example, in this factor 3x, since there's only one term, so we can say this is the leading term of this factor. So we will write that f behaves like 3x times, for the second factor, 1 minus 2x, the leading term is minus 2x. So we will write multiplied with minus 2x. And then for the third factor, which is x minus 1 squared, the leading term, if we will expand this, is x squared. So we will multiply with x squared. And then for the last factor, which is x plus 1 cubed, if we will expand this, the leading term will be x cubed. So we will multiply this with x cubed. So you can see that these are the product of all the leading terms of each factor. So multiplying this, we will get negative 6x to the 7. So the end behavior, when the power here or the degree is an odd number, and the leading coefficient is a negative, then the end behavior will look like this. Meaning, when x approaches to positive infinity, y approaches to minus infinity. And when x approaches to minus infinity, y is increasing or approaches to positive infinity. So this is how you would describe the end behavior. The next step is to determine where the function is greater than 0 or where the function is less than 0, or simply the sign analysis. So in finding for the sign analysis, we need to list down the zeros in this x-axis. So the zeros of the function or x-intercepts are negative 1, 0, 1/2, and 1. And in these four zeros, it divides the x-axis into 5 intervals. First interval, second interval, third interval, fourth interval, and the fifth interval. And in each interval, we need to identify if the function is a positive or negative, or we need to identify if the graph of the function is above the x-axis or below the x-axis. So let us start selecting in this interval. So from 1 to infinity, we can select any number, which is 2. Then we will evaluate this function when x is equal to 2. When we substituted 2 in this function or in every factor, we will get this value, 6 times negative 3 times 1 and 27. Since we are just interested to find the sign, whether it's positive or negative, if you will multiply this, the sign is a negative or less than 0. Or you can use the information that we got in the end behavior. If you remember, as x approaches to positive infinity, y is decreasing or y approaches to minus infinity. It means to say the end behavior here is minus infinity or negative number. So that's why it is correct that f of 2 is a negative. So we will identify here in this interval that the graph is below or a negative. And then what we can do to find the signs of every interval, we can make use on the multiplicity of each factor. So let us find the multiplicity or power even. So this power even appeared in this factor, which is x minus 1, and the 0 here is 1. So means in this point, in this 0, the graph touches at the 0. So I will write touch. So as we know, when the graph touches, it means to say the graph will never cross in the 0. It will only touch. So if on the right side it's a negative, so the left side is also negative. Or we can say that if the multiplicity is an even and the behavior touches, then the sign of the function is same sign on both sides. But if the multiplicity is an odd, since it crosses, then the sign changes. So the only even multiplicity is at 1, and the rest crosses. So it means to say this is the only zeros where the right side or the left side will be the same sign. So if this is minus, on the left side is also a minus because it touches here. And then, since the rest of the zeros are odd multiplicity, meaning it crosses, the graph crosses in these three zeros. So since the right side is negative, so on the left side, the sign is a positive. And then it will cross again here. If the right side of the 0 is a positive, then the left side is a negative. And then since it will cross again here, if the right side of this 0 is a negative, means the left side is positive. Or what you can do is select any number in this interval, substitute in the function, and get the sign. And you can see that these signs are correct. Now, we can now list where the function is greater than 0 or positive. So f of x is greater than 0 or the graph is above the x-axis at intervals -infinity to -1 and 0 to 1/2. And the function is a negative or the graph is below the x-axis at intervals -1 to 0, then 1/2 to 1, and then 1 to infinity. Take note, you can see that I'm writing here open intervals because what we want here is f of x greater than 0 and f of x less than 0 without equal sign. So you will never include the endpoints. So that's how you will find the sign analysis. Now for the last step, in sketching the graph, let us put all the information that we got in the previous steps. So we can plot the zeros or the x-intercepts. Then after that are the signs. And then the behavior. So for this 0, since it is an odd, the behavior of the function will cross like a curve. And it will start from positive here, so it should be above, and then negative on this side. So the graph will be like that. And then for the next 0, which is this, it's x power 1, it will cross like a line. So it is increasing because on the left side is negative, meaning the graph must be below, and here the graph must be above. The next 0 is 1/2, and it comes from 1 minus 2x, and the power is 1, so it will cross again. Since it's positive here and negative on the right side, so it is a decreasing. And then the last 0 is at 1, and since the power is an even, so it will touch. Since on the sign on the left and on the right is negative, so it is a parabola that opens down. So now we can connect all of this, and then the other one, and then on this part is positive, means above, and then on this part is a negative, means below, and a negative again on this part, so we can write that. And you can confirm that the sign behavior, you can see that the sign behavior is As x approaches to positive infinity, y is decreasing or y approaches to minus infinity. And as x approaches to negative infinity, y is increasing or approaches to positive infinity. So that's all.